This is the Advent of Code Day 5 solution. Today we're being given a two-part input. The first part of our input is stacks of crates, so each crate being named with a letter, and then we're given a list of moves to make. So we're being asked to move, in this first line, one crate from stack 2 to stack 1, and then in this second line we're being asked to do the same thing 3 times, so not to move 3 crates, but to do a move from stack 1 to stack 3 3 times. So we're expected to run all the moves on that set of stacks and then find out what comes out on top of each stack, so what letters at the top. So let's jump in and get started. A big part of the solution today is getting the data into the right format, because once we do, it becomes much easier to solve the problem. So I've split up the files to start, so we've got our stacks, which will load first, and then our moves, which will load second. So they're delivered in one file when you download them, but there's no need to try and load them at the same time. That's just extra effort that doesn't really add anything. So let's figure out first what data structure we're going to try and build. So it would make sense, looking at the data input we've got, to use a stack data structure. Rust doesn't have one of those, but Vector has everything we need. You can insert into the front, and you can also push and pop off the back of the vector. So we can use a vector for our stack, and then represent each stack as an element in a vector. So we can use a vector of vectors to represent this set of stacks. So let's do that. And we know there's going to be 9 stacks. And it doesn't know what type it's going to be, so let's just tell it here so this is clear. And we're going to use bytes to represent each name for a stack, or each name of a crate in a stack, I should say. And then we'll initialize that vector. So for in 0 through 9, we can append 2 stacks with a new vector. So that gives us somewhere to put our data. Now let's read through the input data and add it to these stacks. So let's unwrap the line first, like we do usually. And then the line has a chars function, which gives us back an iterator over the characters in the line. So we're going to want to be looking at what's there. So in some cases there's a blank space because there's nothing on top of that stack. Other cases we're looking for a right bracket or a left bracket to tell us where the start of a crate is. So let's have that. And that will need to be mutable because it's an iterator. We'll be iterating through it and changing it. And then we can iterate 9 times. We know we're looking for 9 stacks. And then we can grab chunk by chunk out of the input line. So we'll do line chars dot next chunk. And we want 3 at a time. And this is a, figure out in a second, this is an unstable feature, but that's okay. If let OK chunk equals that. I'm missing some syntax. There we go. Cool. And then IntelliJ will sort this out for us. That's an unstable feature. We want to import it because it's useful to us. So looking at the input format, by grabbing 3 out on a line where we are getting results on every character, or on every chunk even, reading 3 will read left bracket, letter, right bracket, and then leave a space behind. So we don't want to read 4 chunks because there's no space at the end of the line. So we want to read 3 at a time and then consume an extra value out of the iterator every time we successfully read something. So let's, after our if, remember to do linechars.next. Okay, and then if our first character in our chunk is a left bracket, then we've got a crate, and we can add that crate to our stack. So we can have the stack that we're currently working on, insert at the front in position 0, chunk 1, so that's the letter for the crate, second position in the array, as a U8. And then finally, we can just return our stacks. and we need to tell it what type we want to return. There we go. So that will load our stacks up. Now we need to load our moves. We'll check on the format for those. So that is text, number, so number of iterations to do, text, number, all separated by spaces. So we can extract this format much more easily than we could with the previous one. So we'll do a read lines and we'll go functional this time. So we'll map line by line. And then for each line, let's unwrap it. And we can then split the line up on spaces and collect that into a vector so we can index into it easily. And that should be a string reference after the split, not a string. And then we can return the three numbers we care about, which is the number of times to do moves and the two columns to swap, or two stacks to swap. So first value will be parts 1. So 0 is text, 1 is the number of iterations. Parse that as an i32 and unwrap the value. And then for parts 3 and 5, we're going to parse as usize because we want to be able to use the values to index into a vector. So let's do that. And 5. There we go. And then we need to tell it what type we want to return. So we'll collect and do that, which is a vec of i32 usize. So a vector of tuples. So that's all of our input loaded. Now we can move on and solve the problem. Let's start by calling the two functions we've just written. So let stacks equal load stacks. And I'm making that mutable because we're going to be moving things between stacks. And then moves. Okay. And then we can run through all the moves. And we can't use move because that's going to be a keyword, so let's just call it the move. Cool. And we can iterate through the same number of times as we're told to do this task. So from 0 up to the first value in that tuple. And we don't need that variable, we're just going to do this number of times. And then we can grab the value off the stack that we're removing from. So stacks at the move, and then let's remind ourselves which way around we're going. So we're taking from the first number to the second number. So this will be move 1, pop, and unwrap. And then that gives us the crate we're moving. So that can be just crate. And then we can move that onto the other stack that we're going to add this to at the move 2 and push the temporary value. And I've just spotted a mistake here. So if we were to do it like this, we've loaded in values from moves, which are 1 indexed, not 0 indexed. So we should correct for that in our moves function. So this should be -1, and this should be -1 here as well, to get an index value. Good. So that will give us all of our moves against our stacks. So as I said, much easier once you've got the data loaded into the right format. And then finally, we just need to extract out the final result, the text of the top letters. So the top value for each crate, the top of the stack. So let's do that. So we can take the stacks and extract the top value. So we'll get an iterator and map it. And that'll be a stack. Get the last value from it, unwrap that and copy it, because it comes out as a reference when you grab last. And then we can collect. And that should be nearly happy, although let's just wrap that. So that will give us back a vector of U8, a vector of bytes. So we can convert that straight to a string, make it easier to print out and see. From UTF-8, there we go. There we go, and we can print out the result. Oh, I need to unwrap the from UTF-8, that can fail. There we go. Let's run that and see how it does. Kick it off with cargo run, and we've got a couple of errors. So first issue is our load moves is not returning a value. So we've got a semicolon in there that we don't want. And then we've also got an issue, okay, we've used a keyword as a variable name, so let's fix that. So the first thing to fix is this extra semicolon. We don't need that. We want the value to be returned, and that's got rid of the warning there, so we were being told about that. And then crate. Clearly I knew that was a bad idea because I've already called the thing we're pushing temp, so that should fix those two issues. Let's get back and run it. Okay, let's give that a run. And this time it gives us back a string, which is what we were after. So let's go and paste that into the website and see if it's the right answer. Moment of truth. Excellent, good stuff. We can move on to part 2. It's looking like part 2 is going to be much nicer to us than part 1, which really made us work. So they're telling us it's the wrong model of crane. It's a model 9001, not a model 9000. And rather than using the number of crates to move in each instruction as do one move, then one move, then one move, it's move a batch of this size. So if we come up to the example we were given before, where we've got move 3 from 1 to 3, rather than picking up the top crate, then the next crate, then the next crate, and moving them to column 3, it's going to take a batch of 3 at once and move them across. And that means that the order is the opposite to what it would have been before we moved. So that's going to change things up slightly, but it doesn't change how we load the data. So it's just going to be a tweak to how we transfer data when we're operating the crane. So let's jump into our IDE and solve this. Let's start by copying what we've already done, because we're going to do something similar, just with slightly different logic. And it's particularly important that we copy stacks, otherwise we'd start from the thing that we've mutated in part 1, and we'd end up working off the output of part 1 rather than the input of part 1, end up with the wrong answer. So we will run through our moves. This time we don't need to do the moves one by one, so we'll get rid of the loop. Tidy that up. And then we want to select the stack we're going to work with, stack we're going to take values from. So let's start with that. And that'll be stacks at the move 1, so the from stack. And that will be easiest at clone. We don't want to deal with trying to move references into new locations. So then taking that from stack, we want to take the top part of it off and leave the bottom part of it in place. So let's split it in 2. Split at. And that can be split at the... well, you need to split a certain distance from the end. We're taking the certain number of elements off the top. So we want to take the size of from stack and then subtract off the amount to move. And that'll mean to need to be converted to a U size because it's an I32. And that will then give us the top part. That's the slice that we're going to move. Or rather, it'll give us both. It'll give us the bit that we're going to move and the bit that we're going to keep. So let's keep those in variables. So we'll keep the lower part and move the upper part. Then we can get rid of these bits and we can say put the bottom part into the current stack. So we'll take stacks at the move 1 should be keep, and that's a slice, so we can't assign it to a vector. We'll just do a from on that to convert it back into a vector. And then for the upper part, we want to take, that's number 2, and we want to add on everything from the to move. So there's a helpful method on vec, which is a extend from slice. So it'll take everything in the slice and append it to the vector. So let's do that, and that can be the to move. And again, let's be careful here not to take references to what's already in the other stack, and we'll clone that so that we get nice, clean, and separate values. So that should do it. Let's tidy up the printing so we can see what we're looking at and see how that runs. Kick it off with cargo run, and it's giving us back a value, so hopefully that's right. Let's try it out. So we'll pop that in, and we are right. Fantastic. So second part definitely easier than the first part, but that was a good challenge today, and I will see you tomorrow for the next one.